Today we are going to start with chapter 3, Atoms and Molecules. In the first column, explanation about atoms is given by different Indian and Greek philosophers. Like Maharishi Kannad, he explained that when we divide matter, we get smaller and smaller particles, and ultimately a stage comes when the smallest particles cannot be further subdivided. He named these particles as Parmanu. Similarly, another Greek philosopher, Democritus, he named these indivisible particles as atoms. Then, different scientists were curious to know how these atoms combine with each other, and laws of chemical combinations were proposed by Lavoisier and Joseph L. Proust. That is, which laws these atoms follow in order to combine with each other. So, the first law explained here is law of conservation of mass. This law states that mass can neither be created nor destroyed in a chemical reaction. So, for example, in a chemical reaction, when reactants change to form products, mass of reactants will always remain equal to the mass of products. So, if we take this activity 3.1, in this activity, if you see this figure, it is given here, a conical flask is taken, and then small ignition tube is taken. So we will take one solution of one reactant in conical flask and the other reactant in ignition tube. So like different sets of chemicals are given. Copper sulfate and sodium carbonate we will take as reactants. Then we can take barium chloride and sodium sulfate as reactants. We can take lead nitrate and sodium chloride as reactants. So one of the reactants like X we will place in the ignition tube, Y we will place in the conical flask. We have put a cork here so that the gases evolved during this reaction may not escape out. So what we have to do is initially we have to hang the ignition tube in the flask carefully so that the solutions do not mix with each other. Okay, and then after that we will have to weigh the flask with its contents carefully. So before the reaction, we will take weight of the flask with its contents. Once the weight is taken, we will tilt and swirl the flask so that the solutions X and Y get mixed, and then we will weigh it again. Now the question is, what happens in the reaction flask? Of course, when the two chemicals react with each other, they will produce new substances, products are formed, a chemical reaction takes place. Do you think a chemical reaction has taken place? Yes. Why should we put a cork on the mouth of the flask? So that the evolved gases may not escape out. Does the mass of the flask and its contents change? No, it remains same. So the weight of the flask before the reaction and after the reaction remains same. Next is law of constant proportion.